Induction and deduction are critical topics to understand in machine learning, so let's pause for a moment and go over them in more detail with a segment from Ashok's and my artificial intelligence course. Note especially that machine learning is largely about induction.
Let us look at abduction more closely. To understand the similarities and difference between deduction, abduction, and induction, let us look at the relationship between a rule, cause, and effect. Let's consider a simple rule like if it is cloudy, it rains. So it is cloudy is the cause, it rains is the effect. If it is cloudy, then it rains is the rule.
Another example of a rule would be the rule that Bob hates Joe. So Bob hates Joe, so whenever Joe walks in, Bob leaves. The cause is Joe walking in, the effect is Bob leaving, and the rule is Bob hates Joe.
We've already come across yet another instance of this particular arrangement when we were talking about flu and fever. So the rule might be, if flu, then fever. Flu is the cause, fever is the effect. Now in deduction, in one fundamental kind of inference, we know the rule and the cause, and we need to deduce the effect. So given the rule, if it is cloudy, then it rains. And given the cause, it is cloudy, we can deduce that it rains.
Similarly, in our rule that Bob hates Joe, we can say that if Joe just walked in, we can deduce that Bob will leave.
Or if the rule is if flu, then fever, and we know that Ashok has flu, then we can deduce that Ashok has fever. This is simply an instance of modus ponens, and we discussed this in detail when we were talking about logic. Now let us look at induction. Given a relationship between a cause and an effect, we can try to induce a rule. For example, if we observe repeatedly that when it is cloudy, it rains, then we may induce a rule. If it is cloudy, then it rains.
Same thing with Bob and Joe. If we observe repeatedly that every time Joe arrives, Bob leaves, we can induce a rule that Bob must hate Joe.
If every time a patient goes to a doctor with flu and the patient has fever, then we can induce a rule, if flu, then fever. In case of abduction, given a rule and an effect, we can abduce a cause. As an example, given the rule, if it is cloudy, then it rains, and the effect that it is raining, we can ask ourselves, is it cloudy?
And once again with Bob and Joe, given our rule that Bob hates Joe, and given that we just arrived at a party and we see that Joe is here but not Bob, we might be able to abduce that Bob left when Joe arrived.
Or given the rule, if flu, then fever, and the fact that Ashok has fever, we might be able to abduce that Ashok has flu. First of all, notice that we are back to diagnosis. Diagnosis is an instance of abduction. But notice several other properties. First, deduction is truth-preserving. If the rule is true and the cause is true, we can always guarantee that the effect is true as well. Induction and abduction are not truth-preserving. We may know something about the relationship between cause and effect for some sample. That does not mean that the same relationship holds for the entire population. Induction does not always guarantee correctness. Same for abduction. We may know the rule and the effect, and we may suppose that the cause is true, but that need not necessarily be true. It may be the case if flu, then fever, and Ashok may have fever, but that does not necessarily mean that Ashok has flu. Fever can be caused by many things. The reason that fever does not necessarily mean that Ashok has flu is because there can be multiple causes for the same effect, multiple hypotheses for the same data. This is exactly the problem that we had encountered earlier when we were talking about what makes diagnosis hard. We said that deduction, induction, and abduction are three of the fundamental forms of inference. We can, of course, also combine these inferences. Science is a good example. You and I, as scientists, observe some data about the world. Then we abduce some explanation for it. Having abduced an explanation for it, we induce a rule. Having induced a rule, now we can use deduction to predict new data elements. We go and observe some more. Again, we abduce, induce, deduce. And we continue the cycle. Might the cycle also explain significant part of cognition? Is this what you and I do on a daily basis? Abduce, induce, deduce?
In machine learning, what we're largely interested in doing is induction, taking some data in which we speculate cause and effect relationships exist, and inducing a rule. The rule doesn't actually need to be causal. It's all right if the rule is about correlation. The important thing is inducing a rule that will allow us to make sense of data in the future. That rule can then be applied deductively or abductively. In trading, for example, we might apply that rule deductively to predict what stocks will gain value, or abductively to decide where insider trading has already occurred. So now that you have a good grasp of induction, let's get back to Charles and Michael.